In this video, I'll demonstrate how to analyze well-scanned data within MyAssays Desktop. Scanned data refers to data where each position contains multiple measurements on a 2D grid. This type of measurement may be performed in assays with non-homogeneous samples like cell-based assays. These types of assays can result in uneven cell distribution across the well, and a typical single-read assay may entirely miss the material of interest in a large well format. To create my protocol within the MyAssays Desktop Explorer, I'll select New Protocol to open the New Protocol wizard. I'll select the I will enter or paste in my data option and press Next. The type of data is well-scanned data, and the detection technology for my assay is fluorescence or FLU. Next, we can select the data format, and for my assay, it's a 12 by 8 96 well plate. My assay contains unknowns and blank sample types, and my plate layout matches this layout, with blanks in row A followed by unknowns in singlet. For more information on creating or editing plate layouts, please see the associated video. Next, we have an opportunity to enter our data. We could have selected to import directly from supported file types, but I'll copy and paste my data in. So for my assay, I have a set of data in which each well has been measured in 10 x-axis positions and 10 y-axis positions for a total of 100 measurements per well. You can see the data in a text format here, showing the number of indices and the measurements for each position. So I'll copy and paste directly to this pad and press Next. Here we can name our protocol, add an optional description, and finally see our configuration summary and press Finish to launch the protocol. Once we've launched our protocol, on the Measurements tab, we can see our data with a plate overlay on the right-hand side of the screen. We can view this data with a plate scale, which normalizes the heat map coloration across the plate, or the position scale, which applies a heat map based on the values contained in each position alone. For this protocol, I'd like to set up a simple analysis to identify which samples have the greatest range of activity across the well. If we calculate our results, we can see a sample table displaying the sample ID, positions, and a thumb plot view of the raw FLU with a heat map overlay. I would like to exclude all measurements that fall below the average of the blank samples. So first, I'll open the Properties control and navigate to the Transforms tab. By clicking Add, we can see the list of available transforms. Scan Blank Correction will correct each position with the specified blank group on a point-by-point basis. Scan Flag will allow us to specify a condition, and any measurements that meet the condition will be flagged and excluded from further analysis. Scan Reduction Average will calculate an average based on all non-flagged measurements for each position. Scan Reduction Count will count the number of non-flagged measurements for each position. Scan Reduction Median will calculate the median result for all non-flagged measurements for each position. Scan Reduction Peak will report the peak measurement for each position. Scan Reduction Percentage CV will calculate the percent CV of all non-flagged measurements for each position. And Scan Reduction Deviation will report the SD of all non-flagged measurements for each position. So, to calculate the average of each position, I'll first add the Scan Reduction Average transform and press Create. Once we've added the transform, we can specify which data should be contained on each of the axes, specify the X and Y ranges, and output units. Next, to exclude samples that fall below the average of my blank samples, I'll add the Scan Flag transform. Here we can specify a condition for which measurements should be flagged and excluded. I'll use the expression X is less than blank 1.2. This references the result of our blank sample on matrix 2, the average. I'll also rename the output matrix blank removed. Let's recalculate. Now, on our report, we can see the addition of two columns to our sample table. The first contains the average result, and the second shows the new heat map with measurements lower than the blank average removed. Finally, to determine which of my samples show the highest deviation or greatest activity, I'll add the Scan Standard Deviation transform. I'll use blank removed as the input matrix, and let's recalculate. Now on our report, we can see the addition of an SD column to the sample table, reporting each of the samples' standard deviation. I'd like to make a couple formatting changes to the report to make it easier to see which samples have the highest activity. Under the Properties control on the Matrices tab, I'll add value bars to the SD matrix. This will add a value bar to each sample using the minimum and maximum data values of the matrix as 0% and 100% respectively. I'd also like to sort the sample table to display the highest activity samples first. On the Report tab, I'll click on the Sample Table 1 report element. Under the Sample Data Processing settings, I'll select Order by the SD column, in descending order. Here we can also change the size of the thumb plots appearing in the sample table, under the Thumbplot settings. I'd like to see them a little larger, so I'll enter 100 for the plot width and height. I'd also like to add a matrix table report element. I'll click Add Element and select Matrix Table. This will display the thumb plots in a matrix format. The results can be displayed combined into a single table or in separate tables. I'll leave them combined into a single matrix table and add the sheet name Matrix. This will display this report element on a separate sheet from the sample table, which I would like to appear on a sheet named Results. Let's recalculate. Now on our report, you can see that the thumb plots appear larger in our sample table, which is now ordered by the SD column in descending order. The value bars help us visualize the difference between the results, and we can clearly see the sample with the highest SD value appears first. On the Matrix tab, we can see the matrix table displaying the raw, average, blank removed, and SD results. If you have any questions about how to create a protocol for your well scan analysis, please email us at support@myassays.com.